Well, after the last two videos, this video is going to be a snooze fest. Am I right? So in this video anyway, short and quick and smooth and sweet, we're going to factor completely so that we can continue to make a rough sketch, making it even more accurate than, just a big squiggly line. And then we're also going to take a look at the remainder theorem. So first of all, let's factor completely from one given 0. So let's say that our function is f of x is equal to x to the fourth plus 2x to the third minus 5x squared minus 6x. And I'm going to tell you that x equals -1 is our given root or our given 0. So what we can do is, first of all, factor out anything common to all 4 of those terms, and then use synthetic division to kind of knock it down into something more easily factorable. Well, like I said, first of all, can you factor out anything common to all of the terms? Yep, I can factor out an x. I'm left with x cubed plus 2x squared minus 5x minus 6. Now, hold on to that x. It doesn't just vaporize. It's going to come back into play here in a minute. Then, I don't know, I can't factor by grouping. It's, of course, not a trinomial, nothing perfect squares. Ugh, yuck. All right, so we're just going to do synthetic division. So -1, and then my coefficients are 1, 2, -5, -6. Drop it like it's hot. Multiply, atom, multiply, atom, multiply, and then yes, woohoo! We always want to have a 0 there, because if we have a 0, we know that we have what's called a depressed polynomial. So x squared plus 1x minus 6. Remember, it's depressed because it's 1 degree smaller than what we started with. So x to the third becomes x squared. Now, that's something that I can just factor in my head. I know two numbers that multiply to -6 but add up to +1 would be 3 and -2. So x plus 3, x minus 2 is how that factors. Now, I also need to bring back into play the -1, which came from the factor x plus 1 is equal to 0. I also need to bring back the x that I factored out to begin with. So when I do a complete factorization, I get f of x is equal to x times x plus 1 times x plus 3 times x minus 2. Now, just for the fun of it, let's go ahead and make a rough sketch. So I'm going to come over here and make myself a quick sketch. Remember, that's the whole point of this entire chapter, is to be able to make a rough sketch of a polynomial function. Well, based on the fact that this is even, I know that I'm going to have the same end behavior, and I better have 3 turns. So let's see if I can make that magic happen. I have a 0 at 0. I have a 0 at -1. So this is x equals 0, x equals -1, x equals -3. I had a 0 here and here. I also have a 0 at x is equal to 2. So that's going to be right about here. Okay, can I make 3 turns with the same end behavior heading upward because I began with a +1 as a leading coefficient? I sure can. So that's a pretty decent looking graph. Now, synthetic division made that whole process so much easier, and our on-fleek factoring skills. All right, second thing and final thing is the remainder theorem. So the remainder theorem is something you might use someday if you're working in maybe a financial field or something where you're analyzing a function that has lots of terms. So what I'm going to do after I change colors on my pen here is take a look at the remainder theorem. Let's say that we have this polynomial function. I'm going to say polynomial p of x, and it is 3x to the 5th plus 6x to the 4th minus 8x to the 3rd minus 1x squared plus 12x minus 10. And oh, I don't know, just for the fun of it, let's say that this is a polynomial function that represents the price of producing maybe, let's say, washing machines. I don't know. So if you are a factory making washing machines, if you are sitting in the front office as the chief financial officer maybe, you could evaluate the price of producing 6 washing machines. So to find P of 6, we can use the remainder theorem, which just says take that 6 and use synthetic division to evaluate the function at 6. So now I am going to need to use a calculator because my numbers are probably going to get either really big or really small pretty fast. So don't be afraid to use your calculator when you're using the remainder theorem. And just, watch your math. All right, so we're going to drop it like it's hot. We're going to multiply. Or add, 6 plus 18 gave me 24. Multiply now, 6 times 24 was 144. And then we add. That's 136. Now I need to multiply 6 times 136. This is getting big fast. 816. And then we add 815. We multiply 6 times 815 is 4,890. And we add, and then we get 4,902. Now we multiply 6 times 4,902 is going to be in the ballpark of, 29,412. And then one last addition, 29,402. So after using the remainder theorem, I can say that P of 6 is equal to 29,402. And we're done. Synthetic division is the coolest thing ever.